Hey everybody, in this video, we are solving an equation containing two radicals, and it wouldn't be so bad containing two radicals if this one right here were a zero, because I would just bring one radical to the other side. Each would be isolated. I would square both sides and okay, no problem. Great. But in our efforts, we talked about in the last video, I believe, how we want to isolate a radical first in this case. In our effort to do that, perhaps we're trying to get this radical alone. So we bring this over to the other side. It gets a little messy because I will have the square root of 2x plus 3 equals 1, which was already over here hanging out, right? Plus, it was negative out in front, so it becomes plus the square root of x plus 1. I don't know how loud it is outside for you guys to hear, but basically, there's a guy outside with a leaf blower, and it's not really for the leaves. This guy does this like once a week, maintenance guy at my apartment building. And I used to think it was weird because he's outside right now, but he's going to come through and do the hallways with the leaf blower next. Side quest, side story. But he, like, instead of sweeping our halls and stairwells, because it's not like carpeted, he doesn't have to like vacuum it, but just sweep it. Instead of sweeping it, the guy comes through with a leaf blower and he blows down all the dust and whatever that might be on the stairs and hallway, and then he sweeps it. And I used to think, what a weirdo. And then I thought, that's brilliant. And I'm absolutely obsessed with it. And I want to get a rechargeable leaf blower to dust under my couches and stuff. Get all the things that the vacuum can't reach and then vacuum it up after. Anyway, I know you don't care, but I am obsessed that this maintenance like cleanup guy uses a leaf blower. I think he's so smart and I think he deserves a raise for being so brilliant. Anyhow, so we isolated one radical, but it's sort of like a catch 22. If you don't know what a catch 22 is, you kind of look it up, but basically it's like you fix one problem only to find out you have another problem or that you've created another problem. Um and it's just going around in circles, right? So even though I fixed one, we're in this paradox where it seems like there's a no-win situation, but really we can resolve this issue. So it's not a true catch 22. So, okay, if I go ahead and I'm going to go based on the index, which is 2, right? I'm going to use that and I'm going to square both sides. So if I square here and I square here, and I also kind of did some foreshadowing, if you have a sum or a difference that you have to square properly. So keep that in mind. Here on the left, the radical and the square, adios. So the only thing I'm left with is 2x plus 3. On the right side, okay? On the right side, we are going to have to basically multiply it by itself, right? So if you want to rewrite it, if it helps you see things better, 1 plus square root x plus 1, what do we get? First times first, 1. Outer, so this is where we run into a problem. We get radical x plus 1. 1 times root x plus 1 is root x plus 1. And then inner, I get another one. And it's not like one's plus and one's minus where I can get rid, right? I now have 2 of them. So I have 1 root x plus 1. I have another root x plus 1. So I have 2 root x plus 1. And then last times last, I have radical times radical becomes squared. So square root and square root, adios. And I'm left with just the x plus 1. I don't really need these parentheses. I'm just doing that to really, point things out. Okay. So like I said, I don't need those. So I have 1 plus 2 square root of x plus 1 plus x plus 1. All right, I just rewrote that, which was silly and a waste of space, but here we are. Okay, so now what I want to do is I'm going to repeat the process. So I need to isolate this radical. Okay, there was nothing I could do about it. It was what it was. So now I'm going to isolate that. So I'm going to subtract. So make sure you are careful with how you do things. So I'm going to subtract x. Okay, so that is just x and that is gone. Then I have 1 plus 1, which was 2, right? 1 and 1 was 2. This does not get touched right now, okay? This 2 is glued to the x plus 1, okay? Don't be silly. So 1 and 1 is 2. Subtract 2. So that and that is gone. 3 minus 2 is 1, and it's positive 1. So on the left side, we have x plus 1, and on the right side, we have 2 square root of x plus 1. Now, I know I said we gotta isolate the radical, but to be honest, it's kind of okay if we leave that 2 there because I just find that if I divide by 2, just make sure you do this properly. If I divide by 2, I end up with a fraction. It looks a little uglier. So not that there's anything wrong with fractions, but you have to make sure you do this part properly. So now on the left side, it's x plus 1 technically, right? Times another x plus 1. So I'm just going to expand this. It'll turn into a quadratic. It won't have a radical. So we're good, right? So that's going to be x squared plus 1x plus 1x is 2x. And then plus 1 times 1 is 1, not 2. 1 times 1 is 1 equals. And on the right side, you're going to end up with 2 squared, which is 4. And then the square root squared, please think about this step, which is just x plus 1, right? So think about it. Let it marinate because I don't want to see you mess that up. And then 4x plus 4 after I distribute that 4. So now after round 2, we have a lovely polynomial equation. We don't have any radicals left floating around. We know we're gonna have to check for extraneous solutions, but it is what it is. It's just happens. So we're gonna bring this over by subtracting 4x. So right now I'll have x squared, 2x minus 4x, so minus 2x. I'm going to bring over the plus 4 by subtracting 4. 1 take away 4, so minus 3 equals 0. I'm going to factor this because that's what we do. I will have x, x3, 1, negative, plus, like that, right? If you can't factor quickly like that, please take your time. Make sure you factor correctly. I will use zero product property, so I'm going to set this and this each equal to 0 independently. Here, I will get x equals negative 1, and here I will get that x equals 3. Now, while these seem all fine and dandy and lovely, we have to go back and check them. They're not as easy as extraneous, where we could just, as rationals, where we could just, check if it's one of my restrictions or not. We really need to make sure. So negative 1 and positive 3, going back, and we're going to test those out. So if I test x equals negative 1, always in the original, not after you squared both sides. Negative 1 times 2 is negative 2 plus 3. That's going to end up being 1. Minus the square root of negative 1 plus 1. Does this equal 1? That becomes root 1 minus square root of 0. Some of you leave things. Oh, I'm so silly. I'm behind the dog. My dog. My cartoon dog. Some of you guys leave root 1 and root 0 in your answers like that. What are we doing, guys? Square root of 1 is 1 minus square root of 0 is 0. 1 minus 0 is 1. 1 equals 1. Check. So it looks to me like negative 1 works. Right? That looks okay to me. So now let's test x equals 3 in the original. So we'll have the square root of 2 times 3 plus 3. Make sure that radical top stays where it needs to be. Square root of 1, x plus 1, 3 plus 1 is 1. Then that is 6 plus 3, which is square root of 9, which is 3. Minus, 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 square root of 4, which is 2. 3 minus 2. 1, 1, 1. 1 equals 1. So that works too. So they both work. and that can happen, okay? So you could have them both work. You could have where neither answer works. It's fine, okay? So we have two valid solutions for this question. So my final answers, which color should I use, I guess? So those are my final solutions. Right over there. My screen, yes. All right. So this one worked out that I ended up with two final solutions. I hope you found that to be helpful. Sorry, my test work on the side was a little messy. And that is the end of this video. Next we will have, solving with a cube root. This one's kind of light. It's cute. You'll like it. So try it by yourself and then come find me in the next video in this playlist. All right. Adios.